You think you got the answer. So, yeah.
Why are we adding BBBB at the end of it?
Because that is replacing the save frame pointer, which we do not care about. Because we have to override the save frame pointer before we get to the return address, which is what we're really after. Does that answer your question?
Yeah, I'm just trying to remember the what's the safe frame buffer again? Pointer.
The save frame pointer is the save frame pointer is basically used by the main function, what called the function that we're overflowing, and EBP is used to reference your local variables and stuff like that. So whenever you call another function and have a new set of local variables, you have to save the previous save frame pointer. That way, when you return into that function again later on, you can restore the frame pointer and keep on using those local variables. So it's just like process net information that you have to keep track of.
So we're overwriting the frame pointer to the previous function then?
Yes, exactly. But we don't really care what it is because it will not be used before we start executing our shell code. So it doesn't matter that it's correct.
So why do we, I'm just trying to remember, why would we overwrite it then if we don't care?
Because we get to it before we get to the return address, so we have to overwrite it on our journey to the return address. Yep.
All right. What did we guess? 0804829 Bravo.
No, and I know it's not even looking because it's not a stack address. So your address should definitely be on the stack, right? Because that's where your password buffer is. So your address should be something like OSBFFF, something, something, something.
Would the process be to find out what the stack point, the ESP would be after you had loaded all that stuff?
Yeah.
And you're in there.
Dave, again, look like for
580. Yeah, 580.
580. Okay, so let's see. Here's what I'm going to do to solve it. I'll show you guys how I would go about this. So first of all, I'm in the wrong directory because I'm in the hello shell code directory, and I want to be in the same directory as my process, just to make things simple. So I'm going to copy my payload file into the directory where the simple login program is. And I run simple login in the debugger. I'm going to find where that gets call is made instead of breakpoint for after it. That way I know my payload has entered into the process address base because Git has already been called. Then I'm going to scan the stack for my shell code just based on recognition because I have the bytes which are memorized. So I know that the gets call happens in the authorize function, and it looks like it happens right after gets is authorize plus 32. So I know if I set a breakpoint here, I will be breaking in the program after that payload has entered in to the process address space, so I can actually look for it. I'm going to run the program with my payload. That way I can look for my payload in the process address space on the stack. I'm just going to use that x/s command, or x/20x. 20 is arbitrary. I'm just sort of randomly picking a number here. Starting at ESP. I'm using ESP as a reference point because I know ESP is pointing at the stack that my payload is somewhere on the stack because my payload is in a local variable and local variables are on the stack. So x/20x ESP. And that looks familiar, right? So what was your answer, Dave?
580.
How did you arrive at your answer?
I actually set a breakpoint at the, I think the return, just to see what the stack looked like right before I left. I think.
Okay. Yeah, it's possible something
The
happens.
stuff got messed around with stack.
Yeah. So, so it's probably a better strategy just to set the breakpoint for right after your payload comes into the process, just so things haven't had as much time to change. So, using this method, I can see that. Do you have a question? Oh, I'm sorry. Okay. If I used any one of these as my return address, I would be all good in the hood because it would execute these no ops, blah, 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 then hit the first part of my shellcode, and then everything would happen nicely. Another handy way to look for your payload as well is the x/I instruction, which will try to interpret data on the stack as instructions. That way, when you start seeing your shellcode instructions develop, it's kind of a little bit easier to recognize them unless you, can recognize your shellcode just based on the byte pattern. So, for instance, we get some crap in there just because it's trying to interpret, legit stack data as x86 instructions, which are bogus, obviously. But then eventually down here we get to our no ops. So if we were to point the return address of any one of these, it should work. So what I want you guys to do is to pick one of these return addresses, append it to your payload, and then try to use it in your payload file and see if it works. So while you guys are doing that, I'm going to do it up here on my own on the screen, but don't look at the screen. I want you guys to try to do it independently as well. And you may or may not have success depending on which address that you choose. Theoretically, any one of these should work, but some of them might not. See, and I'll explain why later.
The payload that you ran in the GDB there, is that the shellcode that we put together? Or is that?
Yes.
But does it include did you put a buffer for what would be the return address that we're looking for? Does that add 4 more bytes to it? Right?
I hadn't set that up yet. So the last thing I wrote in my payload was the BBBBB, so there's still room for return address. So you can see my payload file now is BBBBB, is a safe frame pointer. Then this should be the return address, and this is BFFF573, which is this last no op that I see here.
Right. What I was saying is when we're using that payload to figure out what the address would be, but should we put in for
yeah, good point.
like some dummy bytes just so the offset is the same?
In some cases, that is a better method to do. That will never hurt you to do that, but sometimes it doesn't matter. In this case, it doesn't matter. In some cases, it will be. Because sometimes the addresses will change a little bit depending on how big your payload is. So if you're trying to define your addresses based on a 68-byte payload, and then go and finalize your payload to 72 bytes, then all your addresses are a little bit off and your payload crashes because you based all your addresses off of a 68-byte payload, things are a little bit different. In this case, it doesn't matter.
But having all the no ops helps us, right?
Yes, yes, it does.
What was that command that showed each instruction and its address? One of the top.
X/, 10i or 20i, that's an arbitrary number, it's like how many instructions, and then ESP, dollar sign dependent on. I broke an authorized specification typically right after the GITS call, so I knew that my payload would have already entered into the stack at that point. If I had broken before that, my payload wouldn't have been on the stack because the GITS call would have been made. The GITS call would not have been made yet. The GITS call is what's reading in our password attempt to where the payload is coming from. Technically, you could just root to ESP and then try to use like ESP plus some offset as your return address, but it helps to see the actual payload bytes when you're doing this. So it's about time for lunch. I'm curious if you guys would rather me show you what the next lab is going to be so you can think about it or work on it over the lunch break, or would you'd rather just have, ignorant bliss about what the next round of torture will be. Totally up to you. Just let me know what you guys want.
How long will it take?
I'm probably going to give you guys like 30 minutes to an hour on your own. I won't really be walking you through that one. Try to get it done.
How long will it take you to explain it?
5 minutes.
I know you go ahead.
Go ahead.
Okay. All right. Motivated. I like that. So, for those of you still working on the Hello World shellcode, getting it to work, that's okay. I'm just for those of you already done, and I want to think about this over lunch, I want to show you this lab. And the next lab is going to basically be developing real weaponized shellcode that we can use, because this Hello World example is obviously a toy example. So I want you guys to develop something a little bit more realistic that you can use. And so the shellcode we're going to develop is going to spawn a shell, exec.de/bin/sh. That way, if we are exploiting some local Linux root application, something that was like doing some sort of service or process, instead of it doing its normal functionality, it would spawn us a shell, and we could use that shell and have root privileges. So we're going to be developing something like that. So, to get you guys started, you're going to be turning this into shellcode via the same process that I showed you with the Hello World shellcode. And I'm actually going to simplify this for you a little bit more, just to make your life easier. But I recommend that I'll modify the starting file a little bit for you guys. And I recommend you flip back over the Hello World shellcode slides and see how I did that. And then, sort of apply the same process and same transformations to this starting assembly source code file. So before I turn you guys this on that, though, I'm going to actually simplify this this starting file. And what I'm going to do is basically just change this second argument, which is really a array of pointers, to null. Because it turns out that if you just do exec.de/bin/sh with the other parameters as null, it'll still work. So you don't have to do all this other foolishness, because that part is actually kind of hard. If you feel super brave, you can certainly try to transform that into shellcode, but I recommend you just try the easier one first, because it still works perfectly fine. So, I will put up on the screen what to do there. You can find all the source code in the shell_shellcode directory. So yeah, that is what I want you guys to try to turn into shellcode. So I recommend that you just go ahead and make that change to your file. If you want, you can make a backup of the original file if you want to try something harder and turn the original into shellcode, but feel free to just use So some obvious issues you'll face with this are, null bytes, pointer to a string here. That's going to come out to be an absolute address. You'll have to deal with that. There's some other mystery issues that I'm not going to tell you about because I want you to discover them on your own. So yeah, once you try to turn that into shellcode, if you want, if you're feeling really brave too, and you get this done really quickly, you're welcome to try to convert this into like a Perl script, like with Hello World shellcode, and then use it to exploit the simple login program. But I'm not going to ask you guys to do that as part of the lab. That's why I should take credit if you want to try that. You will be using your shellcode on another program, but not simple login. I haven't shown you the other program. So if you finish your shellcode before lunch is over, go ahead and start trying to attack simple login with this.
Is there a way to debug assembly code and use GDB and everything?
Yeah. If you just use GDB and
Do I need to compile it, the ASM with a certain flag?
yeah, you might have to use it. I think it's like a G flag or something. Let me yeah, just -G.
Okay. On the NASM command?
Yeah.
I don't understand that command. There's already a -F and an ELF, whatever that is. Because you find it on the man page.
So it'd be like this.
Put the G first.
Yeah, the ELF is just like telling it to use the ELF format.
Okay. Got it, thanks.
Answer your question. You can do something like this. And I have done some of these before. I just have to write the syntax for it all. So you put your shellcode in something like this. So basically, that was bemoaning having to create the Perl script containing all your opcode bytes, which I agree can be tedious. So if you create your shellcode in a separate file, like this, and put some global labels in there, like shellcode start, shellcode end, which is the same as my shellcode. And then make a C file like this. You could obviously, make it print out, your slash characters and all that as well. Just to create a Perl script. And then just do a while loop, pointers, shellcode start, shellcode end, just convert them as bytes, just print out the hexadecimal bytes. And then to link it all together, you would first compile. But for most of you, I want you to just do this by hand. To get that extra character building experience in. But you're certainly welcome to do something like that I showed you as well.
Literally character building, right?
Yes. Very good. Yay. So I'm curious, what are some unique problems that people have run into when developing the Hello or the shell/bin/sh shell code? Are there anything that you ran into with this that I didn't really talk about with the Hello World shellcode? So one issue is that your /bin/sh string has to be null terminated. Okay. How are you guys dealing with that so far? Yeah. Well, that's one way to deal with it. So one of the real annoying things about this lab is trying to get that /bin/sh string into the stack and have it all ordered correctly and null terminated. Is everyone agree? Yep. Do people want to see an alternative way to deal with that situation? All right. If you want to keep using the stack method, I encourage you to do so, but I will show you another alternative that has its own drawbacks that you could potentially use for developing your shellcode. Yeah.
Do you need a drumstick or a strangle?
No, I do not. Everyone think about that for a while. See what horrendous abuse of x86 code is using to accomplish the goal. So what's happening here is coming along, set EAX to 11, I guess I should do AL 11, whatever. I'm jumping to string location, and I'm immediately calling back the string location return. What gets pushed onto the stack when I do this call? The return address, right? Yeah. And at this point, the return address points to this, these bytes that I just told the assembler to emit. But I never return back to this code, because I call and I just pop the return address off the stack into my register and there. EBX is supposed to point to the pointer to the string. Then I null terminate the string by taking the address of the string plus 7, plus 0, plus 1, plus 2, plus 3, plus 4, plus 5, plus 6, plus 7. I just put a placeholder value there for null. Move CL, ECX is all 0. I XOR ECX out, so move null byte right there. EBX is terminated. There is a drawback to this method. If I was to compile this and run it with NASM and LD, it would crash. If I was to run it as shellcode in our payload, it would work. Does anyone know why? Think of all that's happening with this line right here. All of this code ends up in a text segment of the program. And what this line is essentially doing would be saying, modify your text segment with a null button. If you try to modify your own code as it's running, you're going to cause a segmentation fault because your code is marked read-only generally when your program is executing. So this is trying to modify read-only memory with a null byte when it's trying to alternate the string, and that's going to cause segmentation fault. Why would this work if we used it in an exploit, in a payload? You don't have any idea? Where would this be located, be running, if we use it in a payload? If we use it to exploit something like simple logic? Be on a stack, right? Payload's on the stack. And the stack is writable. So this works nicely, except it's a little bit more of a pain to test out. So if you want to use this method, feel free. I'll leave the code up here. If you want to use a stack method, that's fine too. Either method is valid. And either way you take, you will run into some issues later on down the road if you're trying to use the payload.
Hey, Corey.
Yes.
When you move like ESP into EBX or ECX or whatever, are you just move? How much are you moving? Are you moving the 32 bits that ESP is pointing to? I mean, how much gets carried over when you move ESP over? The value the ESP is pointing to, I should say.
Depends how you're doing it. So if you were to do something like move EBX ESP,
Yep.
this puts the 32-bit address that ESP is pointing at into EBX. So 4 bytes are being moved. Okay.
Okay.
So let's say that ESP points to that. Okay.
Okay.
At this point, if we did that, EBX equals OXBF FF FA12. If we were to do move EBX ESP, we can say
Yeah.
so that would set EBX equal to all right.
Yep.
If you were to do, say you're trying to null terminate your string or something like that,
Yeah.
let's say if we were to do that, that's just moving a single byte because we just specified the 1 byte register, the lowest byte of ECX. So in this case, assuming ESP, the value, the data at ESP is that, we would get something like actually, they're a little bit different because there's a little E in this, but don't worry about it right now. I think what you can do, I know this works with YASM and maybe with the NetWide assembler, is if you want to move a single byte, like explicitly do a single byte, you could do like move EBX byte.
And it would just grab the first byte that of the value that ESP was pointing to.
Yes, and alternatively, I'm not positive about this, but I think you could also do, if you did like BL, the lowest byte of EBX, the assembler would be smart enough to know you're just talking about moving a 1 byte value as well. Yeah, it's because it should be, yeah, it's my mistake. I mean, just do it like that. What I was trying to do is I should have put it like that. It's just to signify there should be no byte there. You really don't have to have it there. It just, makes things a little bit more specific.
It would actually be like that right now?
Yes, because you have to have the in.
Oh, it's space. Oh, of course.
Quotes, that way it knows to use that as a literal value, not as a symbol value.
Got it. So you just make it again. That's a total placeholder.
Yeah, it doesn't have to be there. I was just doing it to make it easier to see what's going on.
Sure. Try that. Thanks.
So it's like harness and do it like this, okay? So for instance, if I wanted to use the hello world shellcode, okay, these are that's just the contents of, those are just the objects in the shellcode outputted by the Perl script I made or whatever. Harness. Make sure you compile the shellcode harness with TCC, by the way, not GCC, otherwise it will not work.
So Corey?
Yes.
So in the previous example we went over before this, when we moved ESP over to one of the registers, I guess that was because the system call expects to see a pointer to the string in that register.
Yes, exactly.
What I'm still trying to figure out is how does it know where it starts reading from that pointer? How far does it know to go? Is it null terminated? Does it keep reading until it hits a null?
Until it hits a null, exactly. So what that means is that your /bin/sh string has to be null terminated.
Yeah, I would think so.
Yes.
Now, for the other two things, because you made it simpler on us, we just have to pass nulls into those other registers.
Yeah.
That's so. If we XOR with itself, that creates a null, right?
It does.
Okay.